All right, folks, we're ready now to go ahead and take our data and do some sweet calculating with it. This sheet, at this point, I hope you've done this. Come on, you can't depend on me to do. I can't be here for you for the rest of your life. You have to be able to move on without me. So here's what we did. We took the mass of the anhydrous, we drove the water out, and that was the remaining magnesium sulfate with no water. That's a 46.899. We subtracted the mass of the evaporating dish, which is the same as the mass of the evaporating dish up here. I mean, it's the same darn thing. And then we subtracted those, and we got the mass of the anhydrous magnesium sulfate. So this is the mass of the magnesium sulfate with no water, and that's the mass of the magnesium sulfate with water. So how are we going to get the mass of the water? What is the mass of the water in that compound? And that's the mass of water in the hydrate. What's the magnesium sulfate? So how do you do that? Well, here's the mass of the magnesium sulfate with water, and here's the mass of the magnesium sulfate without water. So what are you going to do? Come on, you know, subtract them. Do it now. Subtract those two numbers, and you'll get the mass of the water in the compound, and then you're set to do your calculating. All right, so go ahead and subtract those, and hopefully when you do that, you'll come out with the right answer. I have faith in your subtracting ability, and you should have come out with that bad Larry right there. All right, so I did do it for you. But that's it. I'm not doing any more for you. You're going to do the rest. 1.504. So 1.504, I'll write that down. 1.504. And we now have our data table almost complete. You're going to do a mole calculation. I ain't doing that for you. We've done enough of those. You do it. So you calculate the moles. Moles of the anhydrous without water magnesium sulfate. So mass of the anhydrous magnesium sulfate. Go ahead and use that mass to calculate that, how many moles that is. And then the moles of the water. How much water was used? There's my mass of my water. So you figure out how many moles of water. You do those calculations. Down here, it does have an observation, you know, what did you observe with the watch glass on there, and you have your calculations. So the calculations are determine the number of moles. You can do that, determine the number of moles. You do that, and you put, okay, here we go. Number of moles, calculate those, put those there. Now it says, using your data, determine the percentage of water in the hydrated crystals. Determine the percentage of water in the hydrated crystals. Percentage of water, percent. Any percent is done by partial divided by whole. If you get 31 out of 35 questions correct on an exam, how do you get your percent? Partial, 31, divided by total, whole, 35. Boom. So how are we going to get percent of water in this compound? So we're going to take the partial and divide it by whole. And it wants the percent of water. So part of the whole mass of the compound is water. So you want to put the mass of the water, which we've calculated. It's on there. I'm not going to do it for you this time. No, I'm not. You do it. And the mass of the whole compound, that's the MgSO4 with the 7 H2Os attached to it. So that's the whole mass. So big mass, divide it into your mass of the water, which we've calculated on that sheet already. Percent, you got to get into multiplied by 100, so get it to a percent multiplied by 100. And come out with what percent of our compound was water. All right, now, why do you have to do that? Well, we can go to the next calculation. Let's see if we can, what did I do with it? Where did it go? Wait a minute. There we go. Next page. All right, there it is. Right there. Okay, and it says assume the correct formula for the hydrated magnesium sulfate is magnesium sulfate. We've already shown you this. I wrote that down for you with 7 waters attached. Using this information, calculate the theoretical percentage of water in the compound. So you're going to use that. Let me get the bigger ready. Oh, I don't know what I do with that. I'll write it again. So you're going to take this whole compound, figure out what its mass is. You know how to do that. Get the mass of a compound. Add them all up. You got magnesium sulfate. You got 4 oxygens here. So get the mass of the magnesium sulfate, then get the mass of 7 waters. Add them together. That gives you the total mass. Partial divided by whole. Partial divided by whole. This is the mass of the whole darn compound. Then we want partial, the water, mass mass of magnesium sulfate with 7 waters, put that here, get the mass of that water, 7 waters, put that here, and come up with theoretically what the percent of water should be. So we have the data from our lab to get that percent, and we also have the theoretical from the compound formula, what that water mass should be percent-wise. So you get those two numbers, and then last but not least, do a percent error. That's the last calculation, percent error. Remember, true minus experimental divided by true. So this mass, or the percent, when you get a percentage for part D, okay, part D, that's using the compound's theoretical formula. That is your true percentage. So whatever you get for that, whatever the percentage, in the lower 50s if I remember right. So when you get a percentage for that, that is your true. So D is your true percent. Part C, which we did from the page before, is your experimental data. That's your experimental. So let's write it like this. Percent error equals true minus experimental, D minus C, part D calculation minus part C calculation divided by part D calculation multiplied by 100, and let's see what we get with a percent error on that. Okay, you're a good lab partner. I'm suspecting we probably did pretty well. All right, we're good lab partner, you and I. So I'm hoping we get under, we always want to get under 10% if we can. Some labs we can't, some labs are really difficult. And I'll say, man, if you get under 30% in this lab, it's hard to do, you're doing well. But this lab, it's pretty straightforward. If you and I were together in lab, this would have taken, you would have taken, by the time you got started and put everything away, cleaned up, about a half hour for you to do it. Of course, I know what I'm doing, and I just fly through it, but take you about a half hour, and then we would do some calculations. So the whole lab would have taken about an hour. Not too bad, pretty quick. So this, we would hope that we would get under 10%. I'm pretty sure we did. I'm pretty sure we got under 5% on that. The numbers look about what they probably should be, what expected to be. All right, so do your percent error, and hopefully we did well. Lab partner, we're good. You and I, we're good. All right. Don't forget to answer those questions. I will not help you with those questions. No, you're on your own. Do those questions, and that wraps up our third lab. All right, great job.